In this question, it is given to you that let n denote the number that turns up when a fair die is rolled. If the probability that the system of equations these three has unique solution is k by 6, then the sum of value of k and all possible values of n is, you have to find the correct choice. First of all, let us find the value of n so that these three equations have a unique solution. We know that if three equations given to us are a1x plus b1y plus c1z equal to d1, similarly two more are there and I want to find the number of solutions. You must be knowing that if d is non-zero, then the system of equations have unique solution. That is, if a1, b1, c1, a2, b2, c2, a3, b3, c3 is not equal to 0, then these three equations will have unique solution. This Cramer's rule you must have studied in 12th class. And using this concept, these three equations will have unique solution if, keeping the coefficients of x, y, z in mind, I get d equal to 1, 1, 1, 2, n, 2, 3, 3, n not equal to 0. It is clear that after simplifying it, we are going to get a quadratic equation in n. That is, we are going to get two values of n. Obviously, without opening this determinant directly, I can say for n equal to 2, this will become 0. For n equal to 3, this will become 0. For any other value of n, it will be non-zero, because a quadratic equation becomes 0 only for two values of variable. That is, for this to be non-zero, n should not be equal to 2 or 3. That is, all possible values of n are 1, 4, 5 and 6, because n is the number which you get by rolling a die, and because 2 and 3 are not allowed, remaining possible values of n are 1, 4, 5, 6. Therefore, the probability that these three equations have unique solution is n is either 1 or 4 or 5 or 6. Therefore, favorable number of cases are 4, total number of cases are 6. Hence, probability of unique solution will be favorable number of cases upon total number of cases. That is, probability of unique solution is equal to 4 by 6. That is, I say the value of k is 4. Hence, sum of value of k and all possible values of n becomes 4 plus 1 plus 4 plus 5 plus 6. This is the value of k and these are the values of n, and the sum becomes 20. Hence, I can say third choice is the correct choice. In this question, you have to find the value of tan inverse of this plus sec inverse of this. Hence, you have to find the correct choice. Obviously, this can be written as 1 plus root 3 upon root 3 into root 3 plus 1, that is 1 by root 3. And obviously, this can be written as under root 4 into 2 plus root 3 upon 3 into 2 plus root 3, that is 2 by root 3. Hence, you have to find the value of tan inverse 1 by root 3 plus sec inverse 2 by root 3. That is 30 degree plus cos inverse root 3 by 2, and we know that this is also 30 degree. Therefore, 30 degree plus 30 degree is equal to 60 degree, and this is equal to pi by 3. Hence, third choice becomes the correct choice.